Okay, let's unpack this. In a world just overflowing with information, you're always looking for that shortcut, that clear path to really understanding what's important. And today we're taking a deep dive into a topic that's, well, it's not just buzzy, it's genuinely transformative. Agentic AI.
That's right. And for this deep dive, we've gathered quite a stack of sources, everything from enterprise reports to specific industry case studies. Our mission really is to cut through all that noise and pull out the most critical insights on agentic AI. What's its real value? What are the hidden costs people maybe aren't talking about? And importantly, how are businesses actually making it work today? We're trying to move beyond the hype, get down to the pragmatic reality of it.
So what does all this mean for you? Maybe you're prepping for a big meeting or just trying to catch up on the latest tech, or perhaps you're just, intensely curious. We're aiming to give you that clear structure, those memorable details, and hopefully those aha moments that make you feel genuinely well-informed. And we'll show you why agentic AI isn't just some future state tech. It's actually here, delivering measurable, substantial return on investment, like right now. So let's start maybe by defining agentic AI, because it really is a significant paradigm shift, isn't it? From how we usually think about artificial intelligence. I mean, for many people, AI still means, systems that just react. You give them a prompt, they create content, text, images, code, whatever.
Right, the generative stuff.
Exactly. But agentic AI is fundamentally different. It's moving beyond that reactive content generation to autonomous systems. Systems that actually have agency.
Agency, yeah. The capacity to choose actions independently.
Right. They can plan, they can reason, they can execute complex, multi-step workflows all on their own to achieve, predefined business goals. It's not just following your instructions step by step.
Yeah.
It's figuring out the best way to get a job done, often without constant human hand-holding.
Precisely. And to get that level of autonomy, agentic AI needs, it relies on a pretty sophisticated architectural foundation. It's not just one piece of software. Think of it more like a suite of interconnected components all working together.
Okay, so what are those core components then?
Well, at its heart, you've got the reasoning engine. This is usually powered by a large language model, an LLM. Think of this as the agent's cognitive core. Its brain, maybe. It orchestrates the decision-making. It breaks down complex goals into smaller, manageable steps. And it coordinates all the other tools and models the agent needs. What's really fascinating now are techniques like chain of thought reasoning.
Chain of thought. What's that exactly?
Yeah. It allows the agent to sort of deliberate, to think through a problem step by step, almost like a person would. It can even show its reasoning, which is huge for self-correction, but also for transparency, building trust in these autonomous systems.
Okay, so it can think. What else?
Well, beyond just thinking, an agent needs to be aware of its surroundings, right? That's where perception and environment sensing come in. And this isn't just about reading text prompts anymore. We're talking multimodal data, taking in info from videos, images, audio, raw numbers, not just words.
So it can see and hear in a sense.
In a sense, yes.
Yeah.
They're constantly querying databases, calling APIs to pull specific info, monitoring real-time data streams. Imagine an agent pulling data from IoT sensors on a factory floor or scanning social media for customer reactions. This constant context feed lets them make truly informed decisions.
Okay, so reasoning, perception, what's next?
Then there's tool use. This is really one of the most defining characteristics. It's how agents actually do things in the world. Translate decisions into real actions.
So it's not just thinking or suggesting, it's actually acting.
Exactly. Unlike an LLM that might just give you advice, an agent can actually interact with external software. It can log into your CRM, update a customer record. It could access your ERP to check inventory levels, send messages via Slack or email, even browse the web to gather information. This is what lets it break out of its training data and actually affect change in your business environment. It's like giving the agent hands and feet.
Okay, that makes sense. What else is crucial?
Another absolutely crucial component is memory. You know how standard LLMs are stateless? Each chat is kind of a fresh start.
Right, they don't remember past conversations unless you feed it back in.
Exactly. But for an agent to handle complex multi-step tasks or, importantly, to learn from its experiences, it needs memory. And we generally talk about two types here. There's short-term memory, which lets it keep track of what it's doing within a specific task or workflow, remembering step 1 when it gets to step 5. And then there's long-term memory. This often uses things like vector databases. It allows the agent to learn from past interactions, store information over time, and recall it when needed. This long-term memory is really key for personalization, for adaptation, for the agent getting smarter and better over time.
So it learns and remembers. That sounds powerful. Is there a final piece?
The final major piece is planning and orchestration. This is where that autonomy really, really shines. You give an agent a high-level goal, something pretty broad like improve customer satisfaction for product X. The agent can then figure out on its own the whole sequence of actions needed to achieve that. It decomposes the goal into smaller, executable subtasks.
So it makes its own plan.
Yes. It might decide, okay, first I need to gather customer feedback from surveys and call logs, then analyze it for common pain points, then maybe coordinate with other systems or even other specialized AI agents to address those points. In these multi-agent systems, you can actually have a primary agent acting like a team lead, directing a whole team of specialized AI agents to tackle a complex problem together.
Wow, okay. Like an AI project manager directing an AI team?
Kind of like that, yeah. Capable of directing a whole digital workforce.
Okay, so with all this AI terminology flying around, generative AI, co-pilots now, agentic AI,
Yeah.
it's easy for things to get a bit blurry. How does agentic AI really stand apart from, say, generative AI like ChatGPT or those AI co-pilots we keep hearing about? Getting this distinction right seems critical for any kind of strategic planning.
Absolutely crucial. Let's break it down simply. Most people now have some experience with generative AI, like ChatGPT. Its main job, content creation. You give it a prompt, it generates text, images, code. It's fundamentally reactive, it waits for your instruction. Each new output typically needs more human guidance. It doesn't really initiate actions beyond creating that content.
Okay, so generative AI creates stuff based on prompts. What about co-pilots then? They seem a step up.
They are. AI co-pilots are more like reactive helpers, often embedded right inside your existing software workflows. A co-pilot might summarize a long document for you, suggest some email replies, maybe help you draft a presentation slide. And this is the key difference, the human user is still the one calling the shots. You're the ultimate decision maker, and you're the one who actually performs the final action. The co-pilot suggests it assists, but you act. It enhances your work, it doesn't replace your action.
Got it. Helper, suggester, but human in charge. So how does agentic AI contrast with both of those?
Agentic AI stands apart because its core focus shifts to proactive decision-making and task execution. Once you give an agentic AI system an objective, a goal, it can operate autonomously for potentially quite extended periods. It plans and executes a whole sequence of actions to achieve that goal, with minimal human intervention needed along the way. It's not just suggesting what to do, it's actually doing it.
Okay, that distinction is much clearer. Proactive doing versus reactive creating or suggesting.
Exactly. Maybe a practical example would help make it even more concrete.
Yeah, that would be great.
Okay, let's take a common business goal. Re-engage dormant customer leads. People who haven't bought anything in a while. So what would a standard generative AI tool do? You might prompt it, write a marketing email for a customer who hasn't purchased in 6 months. It spits out a draft of one email. That's pretty much it. You then have to copy it, paste it, personalize it maybe, send it yourself, track the response.
Yeah.
All manual.
Just gives you the text.
Now, what about an AI co-pilot? Maybe one embedded in your CRM system. It might be smarter. It could suggest a list of customers who fit the dormant criteria. It might even help you populate a pre-written email template with their names.
Yeah.
But you still have to review that list. You still have to approve the email, click send, and then you manage any follow-ups yourself. It helps with discrete parts, but you're driving.
Still requires a lot of human effort.
Definitely. Now, contrast that with an agentic AI system. You give it the high-level goal. Re-engage dormant leads in the Western region and book at least 5 sales meetings this month. What does the agent do? Autonomously, it would likely. First, query your CRM, pull all the leads matching that criteria, then access past purchase data, maybe even support tickets, to understand each lead's specific history and interests. Based on that, generate highly personalized outreach emails for each individual lead, not just a template fill. Then it would figure out the best time to send those emails, schedule them automatically, and it doesn't stop there. It monitors the email open rates, click-through rates, maybe website visits in real time.
So it's tracking the whole interaction.
Yes. And if a lead shows interest, clicks a link, replies, the agent might initiate automated follow-ups. Maybe ping them on LinkedIn if the email doesn't get a response. If the lead expresses interest in a meeting, the agent can interact with their calendar API, propose available times that also work for your sales rep. Once a time is agreed upon, bam, it books the meeting directly onto the sales rep's calendar. And finally, critically, it updates the CRM with all these activities, the outcomes, the meeting details, the whole process end to end.
Wow. Okay, that's a night and day difference.
It really illustrates that core shift, doesn't it? You're not just using an AI tool to help you with a few tasks. You are effectively delegating an entire complex business objective to an autonomous AI agent. You're trusting it to manage the whole thing from start to finish.
And that feels like where the fundamental value proposition for businesses really clicks into place. It's not just automating little tasks here and there. It's automating entire end-to-end business workflows. And that's a huge distinction, isn't it?
Yes.
Especially compared to something like traditional robotic process automation, RPA.
A very important distinction. RPA is fantastic for automating structured, repetitive, rule-based tasks, usually within a single application or maybe two tightly integrated ones. Think data entry, form filling.
Right, the predictable stuff.
But real business processes, as you know, they're rarely that simple or contained. They're often complex, dynamic, they require judgment calls, adaptation, and they almost always cross multiple departments, multiple different software systems.
Like that invoice dispute example you mentioned earlier. CRM, billing, inventory, customer communication, policy lookup.
Precisely. And those are exactly the kinds of processes that create massive operational headaches and bottlenecks in most companies. Why? Because they rely on human handoffs. Information gets passed from person A to system B, then person C needs to make a decision based on data from system D. Each step introduces potential delays, errors, miscommunications. The coordination overhead is huge.
Yeah, the gaps between the steps are often the biggest problem.
Exactly. And that's where agentic AI is uniquely suited, because it combines that reasoning engine, the ability to use various tools, APIs, databases, etc., and its memory. It can navigate these messy, intricate, cross-functional workflows autonomously. It can handle the dynamic nature, the exceptions, the judgment calls, within defined parameters, of course.
So it moves AI from being just a helper tool to being potentially a core operational driver.
That's the shift. The value isn't just about doing one step faster. It's about eliminating the cumulative delays, the errors, the massive coordination cost that happens between all the steps in a complex process. That ability to orchestrate and execute dynamic multi-system workflows autonomously, that's a central, tangible value agentic AI is bringing to the table right now. And it does fundamentally start to redefine work. It positions AI not just as a tool, but potentially as a digital worker or even a digital team member.
Which has huge implications for how you manage teams, structure roles, everything.
Absolutely. Implementation becomes less of a purely technical challenge and more of a strategic and organizational one.
Okay, so we understand the what and the how. Let's talk about the so what.
Yeah.
The tangible results. You mentioned earlier it's delivering ROI now. Beyond the theory, what's the real measure of business impact? Are companies actually seeing significant returns?
That they are. And what's fascinating is that the current deployments, even though many are still relatively early stage, are providing really compelling evidence of significant ROI. We're not just talking small efficiencies. The projections are incredibly optimistic based on early wins. One source mentioned 62% of organizations expect over 100% ROI from their agentic deployments. That builds on already positive experiences they've had with generative AI.
100% ROI. That sounds
So
almost unbelievable.
It does sound high, but it speaks to the power of automating those complex, bottlenecked workflows we were just discussing. Think about it. Agentic AI is really a horizontal technology platform. It's not just for one department. Its sweet spot is those high-volume, multi-step, data-intensive workflows. The ones that span multiple systems and are constantly bogged down by manual coordination and human decision-making delays. That's where the big savings and value unlocks happen.
So where are we seeing this applied most effectively right now? What are some of those high-value use cases across the enterprise?
Oh, it's incredibly broad. Let's tick through a few examples. In finance and accounting, think automating complex accounts, payable processes, investigating invoice disputes automatically, doing real-time expense auditing, continuous compliance checks, even much more sophisticated fraud detection that looks across multiple data sources.
Okay, finance makes sense. What about HR?
Human resources is another big area. Talent acquisition agents, screening resumes against complex criteria, scheduling interviews across multiple calendars, personalized onboarding workflows, even 247 employee assistants that can handle complex policy questions or benefits inquiries accurately.
IT and cybersecurity must be prime candidates too.
Absolutely. IT and cybersecurity. Think ITSM, automation handling, password resets, software access requests without human intervention. Continuous network monitoring is huge, and even autonomous threat investigation and mitigation, like an agent detecting a suspicious activity, verifying it, and automatically isolating the affected device from the network, plus automated security compliance reviews.
Customer service seems like an obvious fit as well.
Definitely. Customer service. Agents handling entire cases, autonomously authentication, checking order history, processing refunds, scheduling follow-ups. This frees up human agents for the really complex, empathetic interactions. Agents can even identify potential upsell or cross-sell opportunities during service interactions.
And sales and marketing. You mentioned re-engaging leads.
Yes, sales and marketing are embracing this. We're seeing the rise of autonomous SDRs, sales development reps, agents that can handle prospecting, qualifying leads, nurturing them 247 with personalized outreach, and even booking qualified meetings onto a human salesperson's calendar. Also, managing full-cycle content workflows, drafting blog posts or social media campaigns, scheduling them, optimizing based on performance data.
Wow. Okay, one more. Supply chain.
Supply chain and operations is huge too. Demand forecasting using more complex data sets, optimizing delivery scheduling and real-time route adjustments based on traffic and weather, predictive maintenance agents anticipating equipment failures, automatically ordering replacement parts, scheduling technicians, retail inventory optimization, automatically adjusting stock levels and promotions based on real-time sales and local events.
The breadth is just astounding. It really touches almost every part of the business.
It does. And like I said, this isn't just theory. We have concrete metrics coming out from companies that have moved beyond just pilots.
Okay, let's hear some of those. Real numbers really drive it home.
Right. So take H&M in retail. They deployed a virtual shopping assistant. It managed to autonomously resolve 70% of customer queries. And crucially, they saw a 25% increase in conversion rates during interactions handled by the agent.
So direct link to revenue there.
Direct link. In manufacturing, Siemens has a predictive maintenance agent. It analyzes operational data, forecasts potential equipment failures. The result, a 30% decrease in unplanned downtime and a 20% reduction in overall maintenance expenses. That's huge in manufacturing.
Massive savings, yeah. What about finance? You mentioned banks earlier.
Financial services are seeing enormous impact. Bank of America's Erica Assistant, it's handled over 1 billion customer interactions. That led to a 17% decrease in the load on their human call centers. Think of the cost savings there. Or JP Morgan. They have an agentic tool called Coach AI for their wealth advisors. It gives them 95% faster research retrieval during client meetings. What's the impact? A 20% year-over-year increase in asset management sales, and advisors using it grew their client books 50% faster.
Wow, boosting advisor productivity and sales directly.
Exactly. And it's not just customer-facing. Morgan Stanley developed an internal agent, DevGen.ai, to automate rewriting legacy code. They estimate it saved them 300,000 developer hours. Imagine freeing up that much high-skill engineering time.
Incredible. Any other quick examples?
Sure. We see DHL in logistics using AI agents for network optimization, getting a 30% improvement in on-time delivery and 20% fuel cost savings. Mass General Brigham in healthcare automating clinical documentation, cutting physician time spent on it by 60%. A marketing tech company, Kaidera.ai, automating campaign builds, reducing time by 70% and getting 2x higher conversion rates. Even government Singapore's Ask Jamie citizen assistant cut call center volume by 50%.
So the takeaway here really feels consistent across industries and functions. This isn't just about making things a bit faster or cheaper.
No, it's more fundamental.
It's driving tangible business outcomes, increased sales, significantly reduced operational costs, better reliability, improved customer experience by tackling those really complex, multi-step, cross-system workflows that have always caused so much friction and inefficiency inside organizations. It's moving the needle on the metrics that matter.
Precisely. It's targeting the really hard, previously intractable automation challenges.
Okay, given those really impressive returns we just talked about, you might be sitting there thinking, right, where do I sign up? Let's get started. But, and there's always a but, isn't there? Here's where the pragmatic assessment comes in. Achieving that kind of ROI requires a pretty significant multifaceted investment. The sources we looked at consistently describe it as an iceberg. And I think that's a perfect metaphor. What you see on the surface is only a small part of the story.
That's exactly right. The cost iceberg concept is absolutely critical for anyone considering this. The visible costs, things like, the monthly LLM API fees, your cloud service subscriptions that might only be 10%, maybe 20% of the true total cost of ownership, the DCO.
Only 10–20%, so the vast majority is hidden.
The vast majority is hidden beneath the surface, yeah. It's tied up in all the essential activities you have to do to make the agent functional, reliable, integrated, and secure within a real enterprise environment.
Okay, so let's dredge up some of those hidden costs. What are the major components of that TCO iceberg?
All right, let's break it down. First, obviously, there's the initial development and procurement, building or licensing the agent itself. And the cost here varies wildly with complexity. A simple single-purpose agent might cost, say, $15,000 to $40,000 to get going, but for more advanced, enterprise-grade systems, especially those involving multiple agents working together or needing very specific domain fine-tuning, pilot projects often start north of $200,000, and they can easily run into the millions for highly customized, bespoke solutions.
Okay, so potentially very high upfront costs just for the agent itself. What's next below the waterline?
Next, and this is a huge one, often seriously underestimated, data preparation and acquisition. High-quality data is the absolute lifeblood of any effective AI. Agents need clean, relevant, timely data to function reliably. The process of collecting that data, cleaning it, labeling it, structuring it, it's often a massive effort. It might even require building entirely new data pipelines just to feed the agent properly. This can be a major project in itself.
Right, garbage in, garbage out applies more than ever.
Absolutely. Then there's the infrastructure. These systems are computationally hungry. They often need high-performance computing, powerful GPUs, robust cloud hosting platforms, significant data storage. Just the ongoing cloud deployment costs alone can easily range from $20,000 to over $70,000 per year, depending on the scale and intensity of use.
Okay, compute and data. What about connecting to everything?
That's the next big chunk. Integration. Agents get their power, as we said, by interacting with your existing enterprise systems, your CRM, your ERP, your databases, communication tools, building the necessary API connectors, making sure the agent can talk reliably to your often legacy platforms. That integration work can be really significant. Costs typically range from $25,000 up to $200,000 or even more, depending on how complex and API-ready your current IT landscape is. It's not just plug and play usually.
So significant effort just to get it hooked into your existing operations.
Definitely. And critically, this is not a set it and forget it technology. You have to budget for ongoing maintenance. This is a substantial recurring operational expense. A good rule of thumb is to budget 15% to 30% of the initial project cost annually just for maintenance.
15 to 30% per year. Wow. What does that cover?
It covers things like retraining the models regularly to prevent performance drift as the world changes, continuously monitoring for accuracy, bias, and cost overruns, updating features, patching security vulnerabilities as they emerge. It's constant care and feeding.
Okay. Are there other hidden costs we should be aware of?
Yes, there are several hidden costs that often catch organizations by surprise. Things like the cost of thoroughly training your staff, not just the technical team, but the end users who will interact with or be supported by the agents. Implementing comprehensive change management programs to handle the shift in roles and processes, that's crucial for adoption. And dealing with technical debt. If you take shortcuts during development to get something out fast, that complexity debt can easily increase your future maintenance and development costs by 20–30%.
It sounds like a complex picture. But you mentioned earlier, perhaps the most significant, maybe the most challenging investment component is the human factor. It's not just software, right? It's about getting the right people.
Absolutely. This might be the single biggest hurdle for many organizations. Building, deploying, and properly managing agentic AI requires a team of highly specialized experts. And these skills are incredibly high demand, making them expensive and hard to find.
So what kind of roles are we talking about? Who do you need on this team?
You typically need data scientists. They handle the data analysis, model validation, ensuring the data quality. Average salaries maybe $120,000 to $200,000 a year. You need machine learning, ML engineers. These are the folks who actually build, train, deploy, and maintain the core AI models. They're often even more expensive, say $130,000 to $250,000. You need specialized software developers with an AI focus to build the core agent architecture, the integrations, the APIs, maybe $100,000 to $200,000. And crucially, you need domain experts, people who deeply understand your specific business, your industry, your processes, your compliance rules. They ensure the agent's logic actually aligns with business reality. Their cost varies varies widely by industry, but think $91,000 to $166,000 or more.
So if you add all that up, even for a small, dedicated in-house team,
You're easily looking at an annual salary cost of $600,000 to over $1 million. And that's a recurring expense year after year. This massive human capital cost is a primary driver pushing many businesses towards outsourcing or using third-party platforms, at least initially.
and it changes the financial planning model too, doesn't it?
Completely. Because these systems require ongoing management and evolution, it's not a one-time project CapEx. It's an ongoing operational expenditure,
Yeah.
OpEx. You need to think about funding this like you fund a permanent R&D team or a core operational function. It's a continuous strategic investment.
Okay. Can you quickly summarize those TCO estimates again, just to put a bow on the cost discussion?
Sure, just rough estimates, obviously, but based on the
Yeah.
sources, for the first year's total cost of ownership, a simple agent, maybe $35,000 to $92,000 all in. An advanced agent likely jumps to $81,000 to $222,000. And a complex enterprise-grade agent, you're probably looking at $808,000 to well over $1.5 million, potentially much more. So yeah, this isn't a trivial decision by any means. It's a significant strategic investment.
Okay. So you understand the potential value, the potentially massive ROI. And you now understand the investment required is also potentially massive, especially considering that whole iceberg. Now, the next really big question for any business leader grappling with this is, okay, how do we actually get this capability? Do we try to build it ourselves, in-house, or do we buy a solution, use a platform, or outsource it? And as you hinted, this isn't just a tech or finance decision. It feels like a fundamental choice about competitive advantage, right?
It absolutely is. It's about deciding where you want to build unique capabilities versus where you leverage existing solutions. Let's break down the build approach first, doing it all in-house. This path offers by far the highest degree of control and the greatest potential for creating truly unique, defensible, competitive advantages. It's probably best suited for automating those core business processes that are absolutely central to your company's unique value proposition.
Okay, so what are the main advantages of going the build route?
There are several key ones. First and foremost, complete control and IP ownership. Your company retains full ownership of everything, the code, the models, the data, all the intellectual property generated. This is absolutely paramount if the agent is executing a proprietary process, like a unique trading algorithm in finance, or a secret sauce manufacturing technique. It allows you to build a competitive moat that others can't easily replicate.
Right, protecting the secret sauce. What else?
Second, you get truly tailored customization. An in-house solution can be meticulously designed from the ground up to fit your company's unique data sources, your very specific workflows, your nuanced business rules and policies. This level of deep customization is often just impossible to achieve with more generic one-size-fits-all third-party platforms.
Okay, control and customization. Security implications, too.
Huge ones. Third advantage, enhanced data privacy and security. By building and running it all in-house, all your sensitive corporate data, your customer data, it remains within your own secure environment. This gives you complete control over data governance, and it can significantly simplify compliance with stringent regulations like GDPR or HIPAA because you're not sending data outside your walls.
Makes sense. Any long-term benefits?
Yes, potentially long-term cost efficiency and strategic flexibility. While the upfront investment is way higher, building in-house means you avoid potentially escalating recurring licensing or subscription fees from vendors. And maybe more importantly, owning the system gives you the strategic freedom to adapt it, innovate on top of it, and expand its capabilities in any direction your business strategy requires without being constrained by a vendor's product roadmap, their priorities, or their future pricing changes.
So lots of powerful reasons to build, especially for strategic stuff. But the drawbacks are pretty significant, too, as we covered.
They are. The flip side is that immense cost and difficulty of hiring and retaining that specialized expert AI team. The typically longer time to market compared to buying something off the shelf. And frankly, the high execution risk if AI engineering isn't already a core competency within your organization. Building these systems well is hard.
Okay, so that's the build side. It sounds powerful but challenging. For many organizations, maybe leveraging third-party platforms or outsourcing development seems like the more pragmatic way to start, right?
Yeah.
Prioritizing speed, maybe lower initial risk.
Exactly. The buy or outsource model has its own compelling set of benefits, especially for getting started or for automating less strategic processes.
What are the main draws there?
I'd say the key benefits are, first, accelerated time to value. Using pre-built platforms or experienced outsourcing partners can get solutions deployed and delivering value significantly faster than trying to build everything from scratch in-house. In fast-moving markets, that speed can be a crucial competitive advantage.
Faster deployment. What about cost and risk?
That's the second big one, lower upfront cost and risk. This approach avoids that massive upfront investment and the long-term commitment of hiring a full-time, potentially multi-million-dollar internal AI team. It lets businesses access advanced AI capabilities often through a more predictable, perhaps subscription-based cost model, less capital risk upfront.
And the talent problem.
Solved, potentially. Third benefit, immediate access to specialized global talent. We talked about how fierce the competition for AI talent is. Outsourcing or using a platform effectively gives you access to a global pool of experienced AI engineers and data scientists, completely bypassing that difficult, expensive, and time-consuming internal hiring process.
Okay. Does it simplify the tech side too?
Generally, yes. Fourth benefit, reduced technical complexity. Good enterprise-grade platforms often abstract away a lot of the complex underlying infrastructure management, the MLOps, machine learning operations, the scalability challenges. The vendor handles the plumbing, allowing your business team to focus more on applying the agent to solve your specific business problems, rather than getting bogged down in the complex technology stack needed to support it.
So faster, cheaper upfront, less risk, easier access to talent, less tech hassle. Sounds pretty good. But there must be trade-offs with the buy model, too.
Oh, absolutely. There are significant trade-offs you need to weigh very carefully. The most immediate and obvious one is a loss of control. When you rely on a third-party vendor or platform, you're inherently subject to their roadmap, their feature set, their decisions, and you face the risk of vendor lock-in. Once you've integrated deeply with a specific platform, switching to a different provider later can become technically difficult and extremely expensive.
Okay, loss of control, lock-in. What about customization?
That's usually limited. Customization is generally restricted to the configuration options and flexibility offered by the vendor's platform. This might not be sufficient if you have highly specialized, unique, or complex business requirements that the platform wasn't designed for.
And data privacy. You mentioned that as a pro for build.
It's a potential con for buy. There can be potential data privacy and security concerns if your sensitive corporate or customer information has to be processed or stored on a third party's infrastructure. You need to do extremely thorough due diligence on the vendor's security practices, their compliance certifications, and the contractual protections they offer. But ultimately, your data is leaving your direct control.
Okay. Any long-term strategic risks with buying?
Yes. There is the subtle but important long-term risk of commoditization of core functions. If you and all your competitors end up using the same external agent platform for a particular core business process, while that process might cease to be a source of unique competitive differentiation for you, relying heavily on external agents for functions truly core to your business model could expose you to long-term strategic vulnerabilities if that vendor changes direction, raises prices drastically, or gets acquired.
Right. So it really comes back to that strategic choice. It isn't just about cost or speed. It's about where you want to build unique advantage versus where you just want efficient execution. The sources seem to offer a pretty clear decision framework centered on one key question for your leadership team to ask.
Yes, a very useful framing question. Is the process we want to automate a cost center to be optimized or a value center to be differentiated?
Okay, break that down. What does that mean in practice?
It means looking at the specific workflow. If it's a relatively standardized cost center thing, internal IT help desk automation, basic invoice processing, routine compliance checks where the primary goal is efficiency, consistency, and cost reduction, then buying a proven third-party solution or using an established platform is often the most logical and efficient choice. You're optimizing, not necessarily innovating uniquely here.
Got it. Optimize cost centers via buy. What about value centers?
If the process is a strategic value center, something that directly defines your company's unique market position or core competency, think proprietary R&D processes, unique customer interaction models, secret financial algorithms, specialized diagnostic procedures in healthcare, then the high cost and effort of building a custom, tailored in-house agent should be viewed differently. It's not just an expense. It's a strategic investment in creating, protecting, and enhancing your long-term competitive advantage. It's about owning and controlling the capabilities that make you unique.
That's a really clear way to frame the build versus buy decision. Cost center equals optimize buy. Value center differentiate, build, or partner very carefully.
Exactly. It helps align the sourcing strategy with the overall business strategy.
Okay, so let's say you've decided on your approach. Maybe you're starting with a pilot. Now we need to talk about actually managing these things. What seems fascinating and maybe a bit scary is that the very autonomy that makes agentic AI so powerful also introduces a whole new level of risks, right? Traditional IT governance just doesn't seem cut out for this.
You've hit on a critical point. Traditional, often static, IT governance models, the ones based on predictable workflows, predefined rules, and lots of manual checks and balances, they are simply insufficient for managing systems that can potentially make and execute thousands of independent decisions every day. Successfully deploying and scaling these agents requires a fundamentally new, more dynamic paradigm. We need robust agentic governance and a specialized operational discipline, sometimes called agent ops, to ensure these systems remain resilient, secure, aligned with business goals, and compliant.
Okay, agentic governance. What does that actually look like in practice? It sounds like more than just policies on a shelf.
Oh, much more. It needs to be a proactive, ideally self-regulating model where the AI systems themselves are designed to autonomously adhere to predefined ethical, legal, and operational constraints, but still allow for effective human oversight when needed. It really has to be built on three core pillars.
Three pillars. What's the first one?
The first and perhaps most foundational is data governance. We keep coming back to data because it's everything here. This means ensuring agents are trained on and operate using high-quality, unbiased, relevant, and timely data. It involves having robust processes for monitoring data lineage, knowing exactly where your data came from and how it's been transformed or used, and of course, ensuring strict data privacy and compliance with regulations like GDPR. Actively detecting and mitigating biases in the data is also critical. If the data foundation is flawed, the agent's decisions built on top will inevitably be flawed too.
Okay, solid data foundation is pillar one. What's pillar two?
Pillar two is algorithmic controls. These are the technical guardrails, the safety mechanisms built directly into the agent's operational logic and its interactions. This includes implementing strict, tailored access controls based on the principle of least privilege. An agent should only have access to the systems and data absolutely necessary for its specific tasks, nothing more. You don't want a simple scheduling agent having access to sensitive financial data. It also involves building in technical safeguards like circuit breakers or kill switches that can automatically halt unsafe or runaway operations, and establishing clear, unambiguous logic to gate high-risk decisions, for example, preventing an agent from exceeding a pre-approved budget threshold, or executing a financial trade that falls outside defined compliance parameters without human approval. These are the essential safety nets.
Makes sense. Technical guardrails. What's the third pillar?
The third pillar is human-AI alignment. This is about ensuring that the agent's autonomous actions consistently remain aligned with human values, ethical principles, and the overarching strategic objectives of the organization. The most critical component here is designing and implementing a robust, human-in-the-loop HITL system. Now, this isn't about constantly micromanaging the agent. It's about establishing a clear governance model.
How does that HITL model work typically?
Typically, the AI handles the vast majority of routine tasks autonomously. But high-risk scenarios, decisions with significant financial or reputational impact, complex edge cases the agent wasn't trained on, or ethically ambiguous situations, these are automatically flagged and escalated to a designated human expert for review and final decision-making. And underpinning this entire HITL model, you absolutely must have transparent, immutable, traceable audit logs. Every significant decision, every action taken, whether by the AI or by the human overseer, needs to be logged in a way that's clear and fully accountable. No black boxes when it comes to critical actions.
Right. Accountability is key.
Yeah.
So data, controls, alignment with human oversight. That governance framework sounds essential.
Yeah.
But you also mentioned amplified risks. What are the unique dangers we need to be aware of with autonomous agents?
Yeah, the risk landscape definitely changes and in some ways intensifies. Let's talk about security vulnerabilities first. Because agents interact with potentially many different tools, databases, and APIs, the overall attack surface of your enterprise expands significantly. This opens a door to new classes of threats specifically targeting these agentic systems.
These threats, like what?
Well, for instance, researchers are demonstrating things like memory poisoning. This is where an attacker tries to inject malicious or misleading data into an agent's long-term memory. The goal is to subtly corrupt its future understanding and decision-making, potentially causing it to make harmful choices down the line without anyone realizing the root cause immediately. Then there are sophisticated prompt injection attacks. These try to trick the agent into bypassing its safety controls or instructions, perhaps making it reveal sensitive information or perform actions it shouldn't. And because agents often operate with pre-authorized credentials to access other systems, the risk from insider threats also increases. If a human employee's account with agent directing privileges is compromised, an attacker could potentially instruct the agent to perform malicious actions using its legitimate access.
Wow, okay. Those sound serious. How do you defend against that?
There's no single silver bullet, but a core principle has to be adopting a zero-trust architecture. This means you don't automatically trust any interaction, even if it originates from inside your network. Every action by every agent, every API call needs to be continuously verified, authenticated, and authorized based on least privilege principles. Assume breach, verify constantly.
Zero trust. Got it. What are their major risks?
The second big challenge is accountability and explainability. We touched on this. When an autonomous agent makes a mistake, maybe a costly financial error, or a decision that harms a customer, determining who or what is responsible becomes incredibly complex. Many advanced AI models, especially deep learning models, still operate somewhat like black boxes. It can be really difficult to trace back the exact reasoning path, the specific data points that led to a particular erroneous output or decision. This lack of clear explainability poses a massive challenge for regulatory compliance, for internal investigations, and for effective risk management. You can't fix what you don't understand.
So what's the solution there? More logging?
Better logging is definitely a part of it. A core tenet of agentic governance must be implementing comprehensive decision chain logging. You need detailed, preferably human-readable audit trails that document not just the final action, but the agent's reasoning process. What data did it access? What tools did it use? What intermediate conclusions did it draw for every significant action or decision? You need that transparency to understand the why.
Okay, transparency is key for accountability. What's the third major risk area?
The third is regulatory compliance. This is a huge and rapidly moving target. The legal and regulatory landscape for AI is evolving incredibly quickly around the world. Frameworks like the EU AI Act are introducing risk-based classifications for AI systems and mandating specific requirements, particularly around human oversight, for high-risk applications, especially in sensitive sectors like finance, healthcare, employment, critical infrastructure. The challenge is that the autonomous, often machine-to-machine decision chains common in agentic systems can potentially conflict directly with existing or emerging regulations that implicitly or explicitly assume a human decision-maker must be involved at certain points. This can create significant compliance gaps, maybe ones you're not even aware of until an auditor asks or something goes wrong.
So you could be non-compliant without even realizing it.
It's a real risk. Organizations absolutely must map out the specific regulatory requirements in all the jurisdictions they operate in, and very carefully design their human-in-the-loop systems and governance processes to ensure they meet those requirements fully and continuously. This isn't a one-time check, it's an ongoing obligation as regulations evolve.
Okay, governance provides the framework, but managing these systems day-to-day in production sounds like it needs its own dedicated approach too. You mentioned AgentOps. Is that like DevOps, but for AI agent?
That's a good way to think about it, yeah. It's adapting the principles of DevOps, collaboration, automation, continuous monitoring, rapid iteration to the unique challenges of managing autonomous AI agents in production. It's about ensuring the ongoing reliability, performance, security, and cost-effectiveness of your deployed agents. It's the operational discipline needed for supervising this new kind of digital workforce.
So what are the key practices within AgentOps?
One absolutely foundational practice is continuous monitoring and observability. The old model of doing periodic audits or only reacting when something breaks is completely inadequate for autonomous systems. You need real-time, continuous monitoring dashboards that give you deep visibility into everything the agents are doing. This means tracking not just the technical performance metrics, things like latency, API call, success rates, token usage, computational cost, but also, crucially, tracking business-level metrics. Task completion rates, the quality or accuracy of the agent's outputs, patterns and errors or escalations to humans, alignment with business KPIs. It's a shift from reactive troubleshooting to constant proactive supervision and understanding.
Constant vigilance.
Comprehensive and automated testing. This is critical. Before any new agent, or even just an updated version of an existing agent, is deployed into production, it absolutely must go through a rigorous, multi-layered testing regimen. This should include unit tests for individual components or skills, integration tests to make sure it works correctly with all the external tools and systems it needs to interact with, and regression tests to guarantee that new features or fixes haven't inadvertently broken some existing functionality. And given the complexity and the speed at which these systems can potentially evolve, automating as much of this testing process as possible is essential for maintaining both quality and development velocity. Manual testing just can't keep up.
Automation in testing is key. What about keeping the models themselves up to date?
That's the next crucial part. Strategic model retraining and lifecycle management. AI models are not static artifacts. Their performance will degrade over time. This is called model drift. It happens as the real-world data patterns they operate on inevitably shift and evolve. So you need a formal lifecycle management process. This involves establishing robust feedback loops, using data from your monitoring, from user interactions, from HITL reviews to strategically retrain and update the underlying models periodically. The goal is to ensure the agents evolve and improve, adapting to the changing environment without losing their core knowledge or capabilities. It's about keeping them effective and accurate over the long haul.
Okay, continuous learning for the agents. Any architectural best practices that fall under AgentOps?
Yes, one really important one is emphasizing a composable and stateless design where possible. The idea here is to architect your agents, or at least their core components, as small, focused, and ideally stateless modules or subagents. Think of them like pure functions in programming. Given the same input, they always produce the same output, without relying on hidden internal state.
Why is statelessness so important here?
Stateless components are inherently more predictable. They are much easier to test in isolation. You can often run them in parallel, which significantly improves overall system performance and reliability. This kind of modular composable design makes the entire agentic system much easier to understand, debug when things go wrong, maintain and update safely over time. It helps manage the inherent complexity.
Oh, that makes a lot of sense. Build like Lego blocks.
Kind of, yeah. And it's crucial to understand that implementing this AgentOps discipline, the continuous monitoring, the automated testing, the model lifecycle management, the thoughtful architecture, this isn't just an optional nice to have. It is a non-negotiable cost of doing business safely and effectively with agentic AI at any kind of scale. It requires a dedicated function within your organization.
A dedicated AgentOps team.
Yes. Staffed by people with a unique blend of skills. You need AI expertise, strong software engineering practices, deep understanding of business operations, security awareness. It's a cross-functional capability. This represents a new, often initially hidden, human resource cost and associated tooling investment, but it is absolutely essential. Without robust agent talks, the risks of deploying autonomous agents, security breaches, compliance failures, operational disruptions, spiraling costs, can quickly overwhelm any potential benefits. It's the price of admission for managing autonomy responsibly.
Right, so you can't just deploy agents and hope for the best. You need the governance and the operational rigor.
Absolutely, they go hand in hand.
Okay, so if you're listening to this and you're considering agentic AI for your organization, maybe you're convinced of the potential value, you understand the costs and the risks, how do you actually begin? It sounds like this isn't something you just jump into overnight.
Yeah.
It needs to be a strategic journey, right? Requires careful planning, understanding the landscape.
Precisely. Trying to implement a sudden, large-scale deployment of fully autonomous agents right out of the gate is almost certainly a recipe for failure. Not just because of the technical hurdles, which are significant, but also because of the organizational factors, potential employee resistance, lack of trust, immature governance processes. You need to build up to it.
So what's a more prudent approach? How should organizations think about adoption?
A much more effective and less risky approach is a gradual, phased adoption model. This allows your organization to build trust incrementally, refine your processes as you learn, develop the necessary internal expertise and governance capabilities over time. You can think of this journey, conceptually, as moving progressively from an AI co-pilot stage towards a fully autonomous autopilot stage.
Okay, co-pilot to autopilot. I like that. Can you walk us through those phases?
Sure. Phase 1 is augmentation, or think of it as the co-pilot phase. Here, you start by deploying agents primarily in an advisory or maybe a shadow mode. The agent analyzes the situation, it gathers information, it perhaps suggests a course of action, but a human employee makes the final decision and actually executes the task. The benefits here are huge. You get to validate the agent's accuracy and reliability in a very low-risk environment. You start building AI literacy across your workforce, and critically, you begin building trust in the system's capabilities. People see it working reliably as a helper first.
Okay, start as a helper, build trust. What's phase 2?
Once that trust and reliability are established, you can move to phase 2, partial automation or the supervised assistant. Here, you start delegating certain well-defined, lower-risk, multi-step tasks entirely to the agent. But And this is key. It's still done with strong human-in-the-loop oversight. You need very clear escalation paths for when the agent gets stuck or encounters something unexpected. The initial focus in this phase should be on high-value, relatively narrow use cases where you can demonstrate rapid impact and get buy-in from stakeholders. Quick wins are important here.
Okay, delegate simpler tasks with supervision. What's next? Phase 3.
Phase 3 is orchestration, or the team lead. In this phase, you start trusting agents to manage entire complex workflows end to end. The agent might be orchestrating other systems, coordinating data flows, maybe even directing teams of more specialized, task-specific agents like we discussed earlier. The role of your human employees shifts significantly here. They move from being the primary doers to becoming more like supervisors, exception handlers, and process improvers. They monitor the agent's overall performance, manage the strategic edge cases, look for ways to optimize the process, while the agent handles the bulk of the day-to-day execution with increasing autonomy.
Humans move up the value chain, managing the process and the exceptions.
Yeah.
And the final phase.
The final stage is phase 4. Scaled autonomy, or the autopilot. Here, you have fully autonomous agents deployed reliably and confidently at scale, handling high-impact business functions with minimal routine human intervention. This stage is only really possible or advisable after your organization has built up a truly mature AgentOps function and a robust, tested governance framework in the preceding phases. At this level of maturity, the enterprise can really start to rely on agents as core drivers of efficiency and value, guided by well-established policies and continuous oversight mechanisms. It's a journey, as you said, of incrementally increasing trust, capability, and autonomy.
That phased approach makes a lot of sense. Start small, build trust, scale carefully. But even before embarking on phase 1, it sounds like leadership needs to grapple with some pretty fundamental strategic questions, ones that go way beyond just the technology itself.
Absolutely critical. Before you even commit significant investment, the leadership team really needs to confront some tough questions about organizational readiness.
What are some of those key strategic questions?
Well, first, API and data strategy. Are we actually built for machines? Agentic AI thrives on programmatic access to data and functionality. So the honest question is, are our core enterprise systems, our proprietary data sources, actually accessible via modern, well-documented APIs? Or are they locked away in legacy silos that will require a massive, expensive modernization effort before we can even effectively deploy agents? If your data and systems aren't machine-ready, your agents are going to be severely limited.
Right. Is the plumbing ready? What's another key question?
Second, product and service design. Are our actual offerings agent-ready? Think about the future. As AI agents become more prevalent, maybe even acting as shopping agents for consumers or procurement agents for businesses, are your company's products and services designed in a way that they can be easily understood, compared, ranked, and interacted with by machines? Or is everything designed solely around human visual interfaces and human behaviors? You need to start thinking about how an AI agent customer or partner will perceive and interact with your offerings.
Designing for machine customers. That's a mind bender. Okay, what else?
Third, and this is a huge one, liability and accountability framework. Who is actually responsible when an agent fails? We touched on the complexity earlier. Has your organization established a clear framework for assigning accountability? When an agent inevitably makes a mistake, maybe one that causes financial loss or reputational damage, where does the liability fall? Is it the fault of the underlying AI platform vendor? Is it your business's responsibility for how you configured or trained it? Does the customer bear some risk? These difficult questions about liability must be addressed proactively, legally, and ethically before you deploy agents in critical roles, not after a crisis hits.
Define responsibility up front. Crucial. What about the business model?
Fourth, business model and monetization. How will this ultimately create enterprise value for us? How do you plan to actually monetize the capabilities that agentic AI unlocks? Will you use it primarily for internal cost reduction and efficiency? Will you create new AI-powered subscription services for your customers? Could you engage in gain-sharing agreements with clients based on the performance improvements your agents deliver for them? And strategically, what role do you want your company to play in the emerging agentic ecosystem? Do you want to be a provider of front-end agent interfaces, a supplier of specialized data that other agents consume, an integrator that pulls together different agent capabilities? You need to define your strategic position and value creation model.
Okay, how does it make money or save money? Final question.
And finally, maybe the most fundamental, organizational and cultural readiness. Are we truly prepared for a hybrid workforce? Do you have a company culture that is open and adaptable enough to embrace a new operational model where humans and AI agents routinely collaborate as colleagues on the same teams? And critically, is the leadership prepared to make the necessary, sustained investments in upskilling and reskilling your human workforce? Preparing them for the more strategic, supervisory, exception handling roles that will become increasingly important as agents take on more of the routine, automatable tasks. This cultural and human transformation is often the hardest part, but it's absolutely essential for long-term success.
Those are some deep, challenging questions.
Yeah.
Definitely not just about plugging in some new software.
Not at all. It's a fundamental business transformation.
So wrapping this all up, we've gone through a lot, the definitions, the ROI, the costs, build versus buy, governance, operations, the roadmap. Where does this leave us? What's the final verdict on agentic AI from the sources we reviewed?
I think the evidence presented throughout our deep dive, across all the sources, makes it abundantly clear. Agentic AI is not some speculative, far-off future technology. It is a present-day reality. It's here now. And it is already delivering significant, measurable competitive advantages to the organizations that are early adopters across a really wide array of industries.
So the message isn't wait and see.
Definitely not. Therefore, the critical question for you, listening to this, if you're in a leadership position, really isn't if you should invest in exploring agentic AI. The real questions are when and how you should begin. Waiting on the sidelines, hoping for the technology to become perfectly mature or for the cost to fall dramatically. Frankly, the analysis is just that's a strategic error. Why? Because the primary challenges to successful adoption, as we've discussed, are not purely technological anymore. The tech is rapidly improving. The biggest hurdles are now overwhelmingly organizational, developing the right governance model for autonomy, navigating the complex cultural shift towards a hybrid human-AI workforce, building the crucial internal expertise needed to manage these powerful systems safely and effectively. These are capabilities that cannot be bought off the shelf. They can only be built through hands-on experience, by doing, by learning from pilots.
So the definitive recommendation is?
Begin now, don't wait. The recommended starting point is to identify a significant operational bottleneck within your business, a complex, multi-step workflow that's causing real pain, and launch a strategic, well-defined pilot project targeting that specific area. And the goal of this initial pilot investment should be twofold. First, yes, aim to generate a tangible, measurable return on investment relatively quickly to prove the business case internally and build momentum. But second, and arguably even more importantly in the long run, use that pilot as your learning ground. Use it to begin the essential process of building that internal muscle memory for agentic governance and agent talks, because that foundational expertise, the organizational capability to safely, ethically, and effectively manage an increasingly autonomous digital workforce, that will be your most valuable asset. That will be your true, sustainable, competitive differentiator in the enterprise of the very near future.
That's a powerful closing thought. We've certainly unpacked a lot today, the core definitions, the really incredible ROI potential across industries, but also confronting those real, often hidden costs. We debated the build versus buy dilemma, navigated the complex but critical world of governance and operations. It's become abundantly clear, I think, that agentic AI is far more than just the latest buzzword. It's a fundamental shift.
It really is. And maybe if we connect this back to the bigger picture for you, the listener, it raises an important question to ponder as you go about your work. As these increasingly intelligent, autonomous agents become more prevalent, and they will be what single workflow, what specific process in your world, if it could become truly autonomous, what would absolutely revolutionize your day or perhaps your entire business? And maybe just as importantly, how do you see your role or your team's role needing to evolve as these agents inevitably become more capable, more integrated, essentially becoming essential digital colleagues?
Definitely something to mull over as you go about your day. Thanks so much for joining us on this deep dive into the complex and fascinating world of agentic AI. We really hope you feel more informed, maybe a bit more prepared, and ready to navigate this exciting and rapidly evolving new frontier.